So we have this pottery wheel, has initial angular velocity of 1.5 revolutions per second, or 3 pi radians per second. And in this case, she's dropping a piece of clay onto the pottery wheel, and this is going to change the angular velocity. This is going to change the angular velocity due to the law of conservation of momentum. So we have a uniform disk. Again, this is the mass of the wheel itself. So this is mass equals 5 kilograms, and then radius equals d over 2, or 0.20 meters. We have the mass of the clay, and this is going to be 2.6 kilograms. It is also a flat disk, and we have a radius of 7 centimeters, or 0.07 meters. Again, law of conservation of momentum. And this is going to say that L equals I omega, where I initial omega initial equals I final omega final. So we can say that I initial equals 1 over 2 mass of the disk, or the wheel itself, times radius of the disk squared. And then final will simply be the same thing, mass of the disk, radius of the disk squared, but it'll be plus 1 over 2 mass of the clay, radius of the clay squared. So that means that the final angular velocity equals I initial omega initial over I final, and this is going to equal omega initial, and then it'll be 1 over 2 mdrd squared plus 1 over 2 mcrc squared, and then as a denominator, 1 over 2 mdrd squared. So that'll be our final velocity, and we can solve. So omega final equals, and then this is going to be quite long, 1 over 2, 2.6, 0.07 squared plus 1 over 2, 5.2 squared, and then 3 pi 1 over 2, 5.2 squared. And our omega final equals 8.860 radians per second. This would be your final angular velocity after the disk of clay is dropped onto the wheel. And that's the end of the solution. Thank you for watching.